electric vehicles. There I am leading with the battery. So some people from ex-colleagues, they're concentrating in the electronics, how they, for example, if you are electrically, like cars, how to integrate your, some of the battery, thermal management, so many factors. So I'm telling that since we are a young researcher, at least you learn, and I think all people are using mobile phones. I think all are familiar. What is there inside? All people only know the lithium battery. That's all. Inside, what are the components? Are any people familiar? I think it's difficult. Only people think that it's lithium battery. So I'm going to, like my next presentation, I will like to highlight what is the real battery. For example, some engineers later you're doing any project, you buy from battery packs. What are the real challenges? What is there inside? And sometimes you're good in the, for example, designing the battery system or wireless chargers. So there, I think these some particular topics, maybe particular highlighting the importance of this understanding the fundamentals I'm going to. So without any further delay, so I think previously I was at the National University of Singapore. So you may see that it is near to, so there is one of the top, like although, so presently I based in the Quebec. So this is a French and English speaking province. It is a state. So where is Ontario, is Toronto, and we can see again people have told that what are the possible opportunities. I think in Montreal, where we stayed, the Concordia University, there a lot of, especially the your domain, like electronics and computer engineering is more popular. And also we have another federal university called McGill University. So that will, I'm telling that it's a little bit difficult because so they have some restriction with the number. So I'm telling this, try to look for slightly medium based ranking, so easier for you to get the thing. So and parallelly you can look for Europe. So there are also a lot of opportunities I'm mentioning. So since like your Vivek Singh mentioned that what are possible opportunities. So during that, for example, during BTech programs, sometimes it will be difficult because you people have to lose the 6 months program, or sometimes if you go to, for example, place like Canada, if you are coming to this season, you have to adapt the climate, or sometimes during the December we have some almost 15 to 20 days leave, so almost you're going losing the time. So my suggestion is that if you, during that your BTech program, you want to do anything, sometimes you may lose the thing because so you have to put the exams in the BTU here, and sometimes you go there and they finish the exams also here, they may not consider. So these are little bit difficulties. My suggestion is that since you people wants to do, so at least maybe after your BTech program, try to look for the opportunities. Don't depend on one particular country. Just look in a different university, either Germany, Europe, and different places are there. Accordingly, you can apply. So that will be good opportunities. So again, I'm telling that presently we can see the instead of like Bangalore, we have I think 14. So there we can go to minus 15. So the temperature. So it will vary depending on the. So and also we have some other beautiful seasons. Again with the we may see that color will change. It's like this one because of the climate conditions. So this outline of presentation. So I'm going to mention what are the. I'll try to make it a little bit simpler so that all people have to follow. So I think you may see that research has no boundary. So when I was at National University of Singapore, so we have trained with the various students. They are like, I think some people from +2. So in Singapore, there is the Ministry of Education. Some people are interested, and the advantage of Singapore is almost like 40-kilometer radius. Anybody can come with a train, like they can visit the laboratory and then they can do. So these are, I think when I was at Singapore, and we have trained many students, and similarly with during that high school or junior college, some people have published a paper. If you go to Google, so you see that high school or JC published paper, you can see maybe I think if I remember maybe 20 to 30 papers have been published based on these school projects. I think advantage is that this 1 or 2 publication, irrespective of any category, either they can go to electrical engineering or computer science, or some people are went to the medical. So idea is that go to any lab experience that will be really useful for you, at least like your CV, that will add up. See, people think that okay, this student is already experienced in the lab, so that type of feeling will occur. So that is my opinion. And like many people have presented in the various conferences held in Singapore, and some students are able to present like international conference, example, science, engineering fair, USA, in different places. I think some of the students have been trained from India, few people from India, and also people from like in the US and few other part of the world. So I think at the NUS also, since it was near, so we've been trained at various universities, especially the student exchange programs, and also we collaborated within the NUS and other part of the world. So I think today I'm going to, although I don't want to discuss too much fundamentals, I'll try to focus on, I think the batteries, lithium batteries are one of the important components, or is your electric vehicles, also your mobile phones. I'm going to discuss what are the real components that will be very useful for your like future research. I think regarding the history, general introduction, materials we are known from the long ages. I think especially the silicon age, you see that this will play an important role in the, especially for electronics engineering. So because of the, as you see, that is vacuum tubes and the miniaturized device, for example, computers. That's why, and also we can see that a lot of advancement is also happening in this particular area. Like future, we call as intelligent low carbon age. Why? Because always people are concerned about the environment. For example, how to reduce the CO2 emission. For example, I can see here, for example, Bangalore previously, that once I know that I'm from local. So almost 10 years back, it's like now because of too many vehicles, a lot of dust, and then pollution is, CO2 emission is rising. So for example, when from Canada, there we get 1 to 2. Here you can see the Google, the pollution index may be more than 10 depending on the season. Delhi is very heavier. So idea is that always either you can reduce the pollution using by all electric vehicles, or other option is so to reduce the CO2 emission by other things, some materials. That is the way they're looking, although really complex in terms of the cost and the technology, etc. So coming to the materials, we broadly classified based on utilities, and for example, based on the electronics, sometimes called solid state electronics, silicon, germanium, one of the important materials. Although you people don't worry about, since all manufacturing, all chips coming from the, some, for example, Taiwan or different part of the places are coming. So idea is that suppose if you go for more depth, for example, manufacturing silicon fabric. So I think you people are going to learn more detailed in this particular area. And also, I think these are the things, if you go for more specialized, some people are working with photonics, or some, for example, sensing the materials. There we need some specialized, specialized topics you are going to understand. And today I'm going to focus on the energy storage. That is, that means there are the things, that is common word. So, for example, a lithium battery that can be used for electric vehicles, or mobile phones, or future one run with electric grids, etc. So another one is information engineering, especially the AI and advanced multi-scale modeling, predicting the new materials. Or for example, there is a lot of, if you talk about the autonomous electric vehicles, again the computer science or information engineering play an important role. So coming to the importance of materials, again you see that depending on the climate conditions, especially here, the construction technology is different when compared to here. There they use wood, and also there is a thermal insulation, because the extreme sometimes you may go to -20. So that's why they like heating the system and cooling the technology. Similarly, if you talk about the aerospace industry, because lightweight carbon age materials, also because of this advancement of technology, now compared to the olden time, the flights can travel very faster. That is mainly due to the lightweight and the composite materials. For example, you talk about glass industry, what they call optical science or optical engineering. Again, so we can see there is a lot of advancement is happening in terms of electrochromic windows or laser and optical material, etc. And similarly, in terms of thermoelectric material, for example, you want to heat the material, cooling. So there is a lot of advancement is also happening. Now coming to the materials, either you want to use it for nanophotonics, spintronic, aerospace, and communication, and all the areas the materials are existing. Only depends on the what is your specialty. Accordingly, you have to select the appropriate materials. So these are common. One slide I will tell that if you want to be smart materials, either if you want to be smart city applications, the material play an important role. Or if you talk about solar cells, there also people are looking, and especially these thin films. I think titanium, that these are the layer by layer thin film technology that is also very useful for the resistive switching memory applications. For example, if you talk about the autonomous electric vehicle, like driverless cars, There is a lidar type of sensor. They're very expensive. I think people are looking for the, I think how to reduce the cost. So these are things that are very, very important. And also, I think you are now, people are in 5G, terahertz electronics, and smart materials for the smart grid, electric vehicles, etc. I think since you people are already studying about the chargers, there is a lot of advancements also is happening. So, and similarly, the AI and then material per CO2 capture. Now coming to the renewable energy, we know that always people are talking about green, clean technology, especially place like India, with huge amount of solar energy, that is one of the viable options. Especially the Canada, there is a lot of hydroelectricity stations because of the huge amount of the water, so as a consequence they will store it. And also it depends on the, and also because of the ice and then rainy season. So, and also we have other type of things. So, for example, why the batteries are one of the world. If you talk about any major cities, for example, either Delhi or Bangalore or China or any, including Montreal, always they see the pollution. Mainly 40 to 50% of pollution is from the gasoline-based vehicles. So that's why people are looking: is there any way alternate just to replace the gasoline vehicles by electric vehicles? That is the question mark. Now, main challenge is the cost and safety. So those are all the things to be. So again, if you talk about sometimes, so it depends. Like the same topic, people mix together. So energy, environmental engineering, and then the interdisciplinary. Sometimes you have to, suppose you want to work with the industry. Always you have to work with the basic sciences, mechanical, and automobile. For example, you want to integrate the things, and at the end, for example, if you're in the mining, you want to talk with the chemical engineers. And triple E means engineering and information engineering. At the end, civil engineers are playing important role. For example, you want to be autonomous electric vehicles. There is you want to smart infrastructure. You want to be how the roads infrastructure. All you want to be smart sensor development. Again, we have to work with this one. And at the end is a management. So it is really all are multidisciplinary. That's why it is not like one man show. Once you go to industry, still. So for example, if you talk about the triple E or so communication, again there is a lot of opportunities this particular area. So now coming to the global demand for electric vehicles, as you can see, always keep on rising. I think mainly presently my main dominator is China, because in terms of the fabrication as well as a lot of vehicles are there. So that's why. So now recently there is a huge investment in India also. Especially the main issue is that all the materials locally have to fabricate. Otherwise, if we batteries come from China or the raw material come from China, automatically 20 to 30% of the cost is rising in terms of the, and also we are increasing the CO2 footprint. Because some transportation cost is also included, automatically the cost is rising. So idea is that all the materials, including the chips like our silicon, everything you have to fabricate by locally. That will be in terms of sustainability concept. So I think you can see that there is a different type of, these are North America, like especially, so you can see that they're not like one particular thing, it's a different type of the big car manufacturer. They're spending their own R&D, although they don't really, some of the R&D team, in this particular teams, a lot of electrical, electronic and communication engineering, and including basics and mechanical, all people have to work together. I think that is the way it will work. So that's why it is, once you go to industry or anything, all people have to work together, and some particular things, some basics points you have to understand. So, and this is a small investment in the Quebec, so there with the different type of the companies. So what are the importance of batteries? If you want to store the batteries, for example, solar energy or wind energy, batteries will play an important role. So, or if you talk about smart city, it is nothing but, so it won't emit the CO2 emissions. That is a grid. Now the story is that, so if you talk about the grid storage or you want to be plug-in electric vehicles, we need kilowatt to megawatt range. Automatically we need more raw material. So as a consequence, the cost is a major one, and sustainability is a major issue. So another important point you to remember, I think this rise of crude oil prices, I think it is compared to the last 10 years, the price of petrol or gas like diesel price is rising. So another aspect is that not only cost, so especially the CO2 emission, you can see that within 5 to 10 years, again the values are rising. So idea is that we have to reduce the CO2 emission. So now, anyway, as a consequence of the impact of the air pollution, we know that it is like slowly, so there's a lot of pollution. Another impact factor, this one is that slowly rising the temperature. So for example, more than 10 to 15 years back, especially Bangalore climate is little more. So now slowly automatically maybe 1 to 2 degree difference also we can see. Similarly, all over the, because of this slightly rise of the temperature we can see. Same thing with Canada also in particular places that the ice is melting. So that is due to the effect of the CO2 emission. Now coming to the autonomous electric vehicles, I think all people are, it is self-driving vehicles. So idea is that using this artificial intelligence and then lidar type of sensors. So I think major benefits we know that the driverless vehicles is that at least we can reduce the CO2 emission because it will use as a battery, and also we can reduce the traffic consumption. I think I heard till now India we are not implementing mainly due to the because of, for example, in Bangalore. So many people, I think we are not, sometimes you have to follow the lane systems. So sometimes there is a sensor, especially two-wheeler, sometimes it will go, so it is very difficult to, because they will fix the sensor in a particular direction. So sometimes if you talk about Tesla, some particular high-end models, they have not included, but especially the Bangalore, due to the, whatever, until like, because of the infrastructure, etc. Still, I think these are things that future people will buy. So my opinion is that first they will go to the hybrid electric vehicle. Once technology everything is successful, I think they may go to the, especially the autonomous vehicle. In fact, this technology already existing, especially people are talking about the California. So many people will take the autonomous electric vehicles to go to the reach their destination. So why I am putting this particular slide is that, so there is a lot of opportunities for especially the computer engineers and electrical and especially automobile and mechanical engineering, etc. So the end, it is a multidisciplinary research. So anyway, I think these are the different type of companies, so I don't want to tell the stories. Now people may ask why can't use lead acid battery, why the lithium battery? Mainly due to the lightweight and reasonably good energy density. That's why lithium batteries are very popular. So now coming to the, I think this slide may be very important for you people. I think all people are, maybe once your battery will iPhone, you may see there are any type of phones, you may see this type of particular type of batteries. There may be negative terminal and positive terminal. We don't know what is there inside, so I'm going to explain in the next coming slide what are the important materials with the post positive and cathode and anode and separator, etc. I think this is like 1860, 18 mm, 650 mm length. These called cylindrical cells that are used in your laptops. And future, if you run with electric vehicles, they try to use this type of cylindrical cells, put it in the individual cell, and finally they made a modular scan, a modular case, and finally put this vehicular. These are typical electric vehicular pack look like this way. So again, once we make during this, once the cells are ready, there is a lot of interesting electronics because the sensor design in terms of the what they call as battery management, charging. So there is a lot of interesting things. Still, there is a lot of challenges. For example, you talk about the safety issues, or sometimes batteries is catching fire. So the people will mention that it is either due to the malfunction in the electronic circuits, or there is issue with the material, etc. So the story here is that there is a lot of, if you go for industry, this particular thing, electrical engineer or electronics will play an important role in this particular area. So now coming to this point, if you talk about any Tesla batteries, so this type of 18650, the cell they use, how many cells? It is not like single cells. You remember, they use nearly 7,100 cells. So suppose, for example, you want to be big vehicles, depending on how much energy are, like for example, bus, so they need a more cells. So the story here is that, so it may use something like a cathode, the layer type cathode. There is presently challenge is that we have the limitation in terms of energy density. So for example, some X people or some material manufacturer, they're able to get doubling the energy density. You people can reduce the weight of the batteries. Maybe if you reduce, then you may get something like 3,500 cells, etc. So now it is very important how the research, all the academic research that will leads to the industry. So this is one of the oldest Nobel laureates won the Nobel Prize. So at the end of almost, so I think the first work started in 1972, okay, almost after 50 years, so 49 years they won the Nobel Prize. So remember, so all the original discoveries or anything is coming from the academic, like this type of institution. So industry, they will take our ideas and finally they scale up the thing. So idea is that what we are learning, for example, in education institution, slowly we learn the basics. Later, if you go for BTech or MTech program, or some people are going for research depending on the interest. So at least we can contribute to the society or as well as some real applications. So I think this slide is very important. Some of the slides may be very useful for you. I think all people are familiar if it is lithium battery or any type of lithium or sodium batteries. We need a cathode. So this color the positive electrodes, and anode is the negative electrode. Here we use a graphite. Cathodes, if it is lithium battery, we need a lithium containing inorganic oxide. Remember, it is not like all the lithium. It is not like chunk of the lithium they will use. They will use something like 1 mole of lithium and cobalt, or for example, reduce the cost, they use something like nickel, cobalt, manganese. That's why LMNC, some batteries. For example, future if you run like doing the project or fourth year, you buy a battery packs, so they will mention that LMN, something like NMC, so means nickel, cobalt, manganese. Okay, so this type of combination. I'm going to explain the next slide. What are the real commercial batteries that are, suppose you can buy that one. So what are the limitations, especially in terms of energy density and voltage. So according to restrict that. Although since you people are doing the project, for example, you want to be fast charger or anything you want to do, try to restrict the SOPs, means safety operating procedures suggested by the manufacturer. So and there will be a separator. It is it is like a polymer type of separator. So idea is that without separator, any battery will not work. So sometimes the separator is not good. It leads to short circuit. And sometimes there is lithium dentate close. That's why during long-term cycling, sometimes battery may catch fire during the charge discharge. That's why also people think that okay, I can charge a battery within 2 minutes. I have good charges. Please don't try. So sometimes the battery will catch fire because due to the high current, there is what they call a thermal management. Temperature will rise. So already people have done a lot of industries or manufacturing. People have been attempted with respect to the current. That's why they will tell that depending on the battery manufacturing, there are chargers. So all the current, everything is fixed by. So don't restrict what are the SOPs. Please according to follow the charging protocol suggested by the manufacturer. I think these are some particular, for example, especially engineering people, they will tell SOC means 50%. When you buy a electric vehicle, they will tell okay, my battery this one. They will terms in terms of SOC, DOC. These are the terms they are going to use. And electrolytes are the things, inorganic based electrolytes and ionic liquid polymers. Again, it is very important. Electrolyte is very important. For example, if electrolyte is flammable, sometimes during it will do high current, it will catch fire. So these are a little bit more complex. So I don't want you to discuss too detail in this particular talk. So now principle, it is as I told you that is a layer type structure. So this is a cathode and anode. During charge, lithium move from the cathode to anode, where the electron will pass to next circuit. During discharge, the reverse reaction is occurring. That's why we call it rechargeable batteries. So or secondary batteries. So okay, so you may see that for example, you buy a battery pack. Once you charge this one or this particular positive current, you don't get negative current, then it's really useless. So that's why they call it primary batteries. So always is very important. Suppose once you buy a battery pack, or for example, typically people are working with like EV based. If you buy any pack, people want to study the charging. Again, maybe you may see that voltage protocol means charge voltage, discharge voltage. It is nothing but how much time at a constant current. For example, you apply some particular milliamp, 1 amp, 2 amp, whatever things at a fixed constant current, and voltage is fixed from bottom to, for example, bottom to top. So, and we can measure how much time it will take. Based on that one, you can calculate the capacity or energy density or power density. Again, it depends on which one you want. All the, I would say, get a meaningful information. So I'm going to skip more details. Again, since you people are not interested about the new material discovery, still as a layman, if you want to be high energy density or power density, we have to look for the voltage difference top minus bottom and multiplied by capacity. That is very, very important. And also it's very important, sometimes you go not to see sometimes battery is catching fire, so electrolyte must be stable, or sometimes there is an issue with the electrolyte, or some people they will tell once I buy a battery I need a 10 years or 20 years, so then mainly to the electrolyte, because electrolyte says it will degrade after years. So sometimes although your cathode anode is good, so these are difficulties. I think this slide is very important for you people. So suppose you talk about any smart battery or smart electric vehicles, it has to work with the climate condition, means sometimes it has to work with the low temperature. For example, Canada, some particular days it may go to some hilly station, extreme low temperature, maybe some cases maybe 20 to -20 to -30 also it will go. So that's why it has to work. And especially place like India, sometimes extreme heating, like for some particular Madhya Pradesh or some wherever some area, sometimes it may go to 55 degrees. So that's why there the people they use to cool the system, we need a affordable or what are the like again the story is that they will use the battery pack, they will consider the heating and cooling system. So you have to take into consideration this. And long life and reliability, for example, once I charge a battery, it has to be, they will suggest 350 miles or 350 kilometers it has to work. So that is very, very important. And anyway, the high capacity energy density coulombic efficiency is very important. It is nothing but during charge discharge, so almost 99% efficiency must be there. And impedance is the one. So what you do with something like electrical impedance, resistance should be minimal, in the sense once you make buy a battery pack. So for example, we have some 50 ohms resistance, 10 ohms. When you buy a pack after 2 years, if it should be something like 20 ohms is fine. It is going to 2000 ohms, something wrong with your battery packs, or slowly it will degrade, or soon it's going to die like that way. So I think fast charging is also a very important point you have to take into consideration. Sometimes people, like all the students, whenever you go to there, similarly like petrol, is there any way to charge a battery within 2 minutes, although we have good infrastructure? I'll tell that little bit difficulties. The problem here is that if it is a bigger, again it is the material fabric, how they are going to fabricating the material. For example, if you have the small particles, you pass the electricity, all material participating in the electrochemical cycling. For example, the same thing, if you do higher current rate, all material may not be participating. So you can see the half of the material is participating. At the end, within 6 minutes, you can see that the same material with 0.10 hours will get higher capacity, whereas 6 minutes. So that is a problem, So that's why it is not the issue with your chargers. It is mainly issue with the materials. So always sometimes you will be patient. So again, the story is that we feel like 2 to 3 hours, or sometimes after 100 kilometers or 200 kilometer driving, so people may take a rest for maybe 5 to 6 hours. So that type of things it will be there. So it is difficult. For example, it's not like you at a stretch you can go to 600 kilometers is very difficult. So that is okay. That is mainly due to your charges. Again, the stories are higher that there is a lot of advancement is happening. There is a wireless chargers technology also is happening. So again, still I'm telling that in terms of the battery pack is concerned, so mainly the graphite is the one, so that making the drawback, so that still it is very difficult because of the what they call intrinsic nature of the material. So that's why the dendritic growth. That's why not avoid that one. People they may use something like overnight charging, or depending on the battery pack manufacturer. Some people are very good. So that way. Anyway, there is a lot of advancement is also happening. I don't want to discuss too many details. I think it is clear for you people why batteries it is not like 2 minutes, 3 minutes or fast charging. So they mainly due to the material limitation. It is like similarly like you take a small brick, you put the water drop by drop, it will wet neatly. You do with the fast, like at a time you can spray, and that only surface is participating, exactly the same story. So with high current, all the material may not be participating. As a consequence, we can get a low energy density or power density, etc. So I think another important point, especially this is not related to you, because since you are electrical, you don't care about I think materials play an important role. Suppose people are looking about the cost, all the materials you have to locally is to produce. So then only, so for example, you are buying from graphite from China or this particular element from China, automatically they will extra cost around 20 to 30% import. All the regulation will cause automatically you have to pay the more price for the battery pack. So that is a major reason. And also we need something like neodymium dysprosium for permanent magnets, and silicon carbide, especially the EV. So that's why electronic. So all the materials play an important. So again, people may ask you that why the battery packs are expensive. Again, that is due to the inside which material they're putting. For example, if you talk about any mining, so cobalt based, nearly 30 tons of the mineral gives like 30 kilograms cobalt, whereas 5 tons of the 60 kilograms of nickel. It means that that's why people for the industry they are looking, so they are looking for nickel rich cathodes. That's why some depending on the particular, now iron based LFP batteries also very popular. So in terms of manufacturing, so mainly 76% is dominated by China, and especially US is 8%, and then again India. I think nowadays there is a lot of investment in this particular area also. So I don't want to skip too much details on this particular area. So slowly I'm mentioning that. So since you are if it are of the mechanical, chemical engineers, I think the people have already developed this particular. People are producing a large scale technique. And for example, you are the electrical engineer. Sometimes you may use some thin film. For example, if you want to go for work in a silicon fabrication technology, there we may use something particular thin film technology that will be to be produced. For example, you see that thin films. So you want to prepare for example, the photonics application. They need a particular size and shapes. For example, you want to be integrated circuits. Again, all the technologies. The only thing is that we need a appropriate fabrication technology. Again, it's a $1 billion industry. So it is very difficult to install especially in each college because of the huge investment and maintenance. So maybe it is possible with the top IITs or IAC. That is also only research lab. For like common like for example, all students want to do project or do this one, a little bit difficult. Mainly it is a big investment and maintenance, and especially for the students you want to do, you dedicatedly work 2 to 3 days because all this vacuum technology to understand. So sometimes you people doing part-time project, it's not like go 1 hour, 2 hour, do project is not possible. So there is a little bit difficulty while doing the experimental techniques. So I think these are the techniques. I don't want to say, especially if people are interested about the integrated circuits. There we're using something like atomic layer deposition, pulse layer. So these are the techniques people want to. These are all things only you learn specifically if you go for the fabrication industry. So anyway, I don't want to touch too many details. Since this particular, maybe we use something like potentiostat, galvanostat, this particular, especially for the EV and impedance analyzer, the high frequency impedance analyzer. I think people are going to study to see the circuits. For example, once you prepare any fabricated circuits, once the circuit is good or circuit, then we can check with the resistance. From there, if it is, for example, fabrication defects, everything we can check this particular technique. I think you people are going to study this one, maybe depending on the not very hi-fi fancy instrument, still with the simple impedance like kit layer, this type of instrument you can see the information. So again, I'm telling that, so one more story is that when more than 25 years back, I used to record one simple X-ray pattern, almost 24 hours overnight. Now with advancement of the detectors, we were able to get within 5 minutes. So again, due to the instrumentation, again, the electrical and electronic engineering will play an important role in the development of the instrumentation, etc. I think I'm going to skip too many details. So still, if you want to do research, any laboratories there, take simple sputtering unit, you can do. Either you want to develop the, for example, chips integrated in the smart card, all the people have been done, or I want to be silicon, take a silicon substrate, there we can do all solid state type of batteries. Although reality is very simple, in order to do this one, really you must try to understand all the more than 6 months or 1 year. That's why it is some particular experimental research. It will take more time, more dedication. So this is a little bit difficulties. Okay, so again the same technology. If you talk about the electrochromics or any other things, we can work. So regarding the electric vehicles, I think all people. So there is a typical batteries. So what I'm mentioning that. So there is the importance of the power electronics, electric machines, and energy management. So it is like all are interdisciplinary. So although some particular topics you work, some people have to develop. So it's not like a one-man show. So and coming to the battery management. So I told you that it is simple cylindrical cells. It is not like simply connecting to the one wire. So we have to nicely solder it. So either depending on how much requirement, accordingly they will put. So the problem here is that you can see clearly, next slide, sorry. So many cells are doing, for example, you see this is the last one, this is really good because 4.2 is going, or some cases these cells are like, so usually the like constant charging, all the cell uniformly has to charge, so that is very, or some particular cells it will not go, so it is not really good. What people will tell that due to your soldering is not good, or your battery management, for example, charging system is not really good. So as a sometimes some particular cells, for example, some particular cell, it may catch fire. So that's why what the people will tell that if the electrical engineer's job responsibility is that this particular stack, if it is there any issue with, means it has to stop the, so that way we can avoid the short circuit or fire the battery. So the problem here, based on my understanding, I was there in the WABC conference with a lot of electrical engineers or people are power electronics specialists. They're telling that sometimes once you catch fire, so the whole, sometimes one particular stack is catching fire, other things also, if it is good cells also going to be dying. So that's why there is a lot of advancement is happening. Suppose the health of the batteries, that's why either sensing management, temperature. So these are all the things is really, once you go more depth, you go to industry, these are the things you are going to learn in future. Similarly, like discharging, all this, when I told you that, so these are the things. So reality is that so many cells uniformly has to either charge or discharge to do. So I'm going to discuss quickly since my time. So these are the typical type of batteries. Once you buy a battery pack, so they call as NCM or NMC. So 81 means 62 means 62% of nickel, 20% of cobalt, and 2% of the 20% of manganese. So that's why different things. So if you buy a battery pack, they will tell SOP saying that this particular battery pack, or we call as LFP, means lithium iron phosphate. So these are things. So the idea here is that, so each, whenever buy a battery pack, so they will mention that with this particular thing, please try to restrict the SOP. So like, okay, you please go to this particular voltage or for whatever the voltage according to, and especially graphite is the one, so it's more popular. So because of the low discharge potential, that will be really good. I think these are the, I don't want to discuss too many details. And so what the take home message for you people, please read the which type of batteries, accordingly restrict the voltage. That is my take home message. So some of the materials we worked with long back at the time, I'm talking about more than 20 years, people have realized, okay, vanadium is very expensive. Recently, I think last month I was there in Germany. Some SAPT is the biggest battery manufacturer. They're still there concentrating on this particular technique. Because why? Because they're looking for high energy density and voltage is good. And sometimes they don't worry about the cost in some special applications. So I think these are the charge and discharge potential of this particular lithium iron phosphate. And again, I'm telling that maybe I'll go through, since this may not be interesting for you. Usually in a laboratory or an industry, they may use something like small scale fabrication. Either they can coat this thing, either binder, current collector, either coat it in aluminum and copper foil, finally roll it, and if they made a button cell, once is good, they go for example, you want to be, for example, later, these are all automated facilities. You go to real industry, so either you want to be pouch cell or you want to be button cell. What are the things you want are only depending on the, for example, your grid system. There we need a big type of the pouch cell they can prepare. Okay, everything is automated, you don't need to work. Again, mainly is a $1 billion industry, so that people have to work in the according to the requirement. So again, as you can see that, suppose for example, if you do the project, you may buy this type of particular pack. So all are existing. So only thing is that depending on really what really you are looking and what is your project objectives, accordingly we have to concentrate. So quickly I will tell that, for example, why the speciality of this material. So you can try to prepare, either you want to be button cell, you can take either cathode and electrolyte, separator, and either you can do the graphite or lithium metal. Finally, the button cell is ready. And these are typical potentiostat, galvanostat. So we are going to monitor the voltage as a function of time, how fast you want to charge or discharge, everything you can do by this. And these are the impedance analyzer. I think it is high frequency. So there we can monitor the with respect to the low and high frequency, and with the various information we can get. So I don't want to discuss too many details. Later, if you go for more specialized, for example, battery, so you're going to learn on more on this particular technique. So again, I'm telling this some particular batteries in the laboratory almost run for 6 months. Practically in lab scale, they go for 50 cycles. In practically for real system, they go for nearly years together. I think it has to work 5 to 10 years. So that's why each battery technology, they put large scale manufacturing. One particular quality control, they put it in the particular industry. It will run for years together, so without any interrupting the system. Because this is very important, for especially for industry, trust is very important. So always the quality control they will do. It is not like giving the good industry, better fabricator. So they will do their own R&D cell. They use each batch. They try to prepare the sample. They will monitor the function exactly like that way. So anyway, I think this is a typical impedance resistance plot is like real and imaginary. So from there we can see, for example, is a 10 ohms. Depending on the voltage, the resistance is. So sometimes people may ask you that, oh, the lithium is expensive, lithium is finishing with any other technology. Yes, sodium is also there. The story is that you see the ionic radius, for example, see this higher automatically it means more ions, and also there is issue with lithium diffusion, etc. Sometimes still more popular presently because of lithium in terms of energy density wise and weight wise is good. Maybe after 5 to 10 years, once technology is matured and people are looking for alternative, they can still maybe another 10 to 15 years, all big fabricators, they stick to the lithium battery only. So I think you may see that the same fellow, you are going 4.2, here is 3.5, automatically the energy density is lower. Maybe electrical engineering may not be interesting because you want to put more cells. So people are looking for especially for good energy density means we need a higher voltage. So I think I don't want to discuss too details again. Some particular area also maybe this is a new this year Nobel Prize. I think in this area also we contributed. So some of the new example. So idea is only for academic research. So it is not like, so the problem is that these materials are reasonably, voltage is good, the capacity or energy density will lower. That's why. So academically we can do some particular things. It is not like tomorrow people are going to replace this. For example, present NMC battery with this particular vanadium based metal organic. So quickly I'll tell, because this may not be interesting for our type, especially graphite is a lot of applications. Either you want to do for batteries, people they may use it for mainly due to the flat potential. That's why. So that is really good. We not to get a good energy density. So I don't want to discuss too many details. So the story is that maybe this slide may be interesting. Thermal runway, sometimes we see some batteries getting bulge, or some people, the car is catching fire. You may see that the mainly due to the people will tell that flammability is one electrolyte, one reason, and also another reason is sometimes due to fast charging, the slowly oxygen will reach the material degradation, and the lithium plating also another reason, and malfunction of the electronic circuits. In the sense, some particular thing, you tell that, okay, you go to the battery charger to some particular voltage, by mistakenly, I don't know how malfunction, still I am a little bit question mark. So how it will go to the higher voltage, or maybe software or some circuit issue, that's as a consequence, likely exceeding the voltage limit, as a consequence it may catch fire, so sometimes your iPhone is catching fire, or car is catching fire, especially car battery. So anyway, these are the different type of things.